Hello everyone, my name is Elvira Rakova and today I would like to show you one of the projects of the use of the air knives in the steel factory. So this is one of the use cases that I really like because it shows how important it is to have a demand side audits. We often focus only on the compressed air room, or auditors focus most on the compressed air room while performing the audits on the leak detection and trying to solve the problem from that angle. Today, I would like to show you how to include the demand side analysis and avoid any misunderstanding also with the customer. So what we have a steel manufacturer that is located in Morocco and produce steel sheets using the cold rolling method. For that, for cleaning of those sheets, was required to have some air to clean it to dry it up. And here, before there were some open tubes, as it usual, traditional in the machines, no engineering nozzles, and client decided to integrate air knives to make the operation more efficient and also to improve the compressed air system performance. Here I would like to tell you that compressed air in this factory is used almost only 90% for the air knives operations. So since it's in Morocco, so here you can see some information about the total cost. And this was the analysis of the compressed air auditing company, of the company that provides the software for the monitoring. And they said, you can still do something here. Good thing, but they started with the operational risks. And the problem was that there was a pressure drop across the system, about 1.6 bar, while pressure fluctuation, it's about 3 bar. So where is the difference in this between pressure drop and pressure fluctuation? Pressure fluctuation were occurring when the system was starting to work. You could see it also in the manometer without the monitoring, and pressure drop were across the system from the machine until the compressor room. And on the other hand, was also found leaks around 13%, that it's quite normal and quite good performance for the system. And the conclusion was to repair first those leaks, redesign compressor room, buy new compressors, probably to compensate those pressure drops, make it more performative, and get also a bigger receiver to compensate those pressure drops. We took another angle that I mentioned before, and we decided to check first how the air was used. So going to this air knives, we checked the data of this air knife. So there was some data on the technical data from the catalog, and here we modeled the projected application. So basically, one air knife consists of various nozzles. You can calculate the amount of these nozzles. You can find also in the catalog the diameter of the orifices for those nozzles, and create the simplified model, well, not simplified model of the air knife. Now I would like to show you how we did it in the EasyCAS software. I would like to open the model. And here you can see the calculation. So don't forget to put input parameters, pressure level at the compressor. And here you can see that nozzle, this is the air knife model, and this is the model of the open pipes. You can easily compare it and see that if we have open pipes here, we need the high pressure, we need about 4.5 bar. There are pressure drops also if we use the same design. And here it is optimized already model with the real operation. The thing is that real pressure that was going at the end of the orifice was about 2 bar, although the machine builders, machine operators, they were expecting to have a 5 bar as they projected this application. However, it was only 2 bar, and the flow rate was about 365 cubic meter per hour. You also can see the cost, operation costs. It's quite a lot, 20,000 if we see here. Sorry, it wasn't. Yeah, so exactly, and but that's not it, because if we go into the detailed application, we start to think how to calculate and how to manage the full system. So here, as I said again, what we did first, the projected application. The projected applications expected to have here 5 bar at the end. And when we analyzes the diameters of the connections that were installed there, and also the tubes that were installed there, we saw that the pressure drop supposed to be 2.3 bar only on those connection. And to operate this kind of system, we had to have the pressure level at the compressor around 8 bar, also with a higher consumption. However, it was not the case. The system was here already delivering around 2 bar, meaning that the projected application was not able to perform, just simply because the pressure drop of around 3 bar that we saw at the machine was exactly what we also modeled. And those pressure drop were caused by the wrong design or the wrong installation. What was the real application? The real application was that here was around 2.5 bar. The force was lower. So here we also modeled the force about 127 Newton. Here the force was, the real one was 17 Newton. The real consumption was also lower. And there was pressure drops, but they were smaller. After we could model and after we can model, we go and create a super component. So basically this a detailed model of the air knife. We take the data from this compressor or from the source model, and we put it in the various plots here, because we had there 2 machines, and each machine had 4 air knives. And what we saw, measurements in the model, that the consumption and the cost were more or less the same, and also that the pressure drop in the diameter of the tubes was about 1.8 bar, and the model 1.6 bar. So as you can see here, the problem of it's not a compressed air room. The problem is that the projected application was not suitable for the system that was the compressed air system that was there before. So because there was very small pipes causing the pressure drops, and also that in general the overall design was not made to operate with the 5 bar with the same application. We have to have a 12 bar pressure at the compressor room. However, installing the air knife, it's a very good idea in comparison to the open pipes, but we always need to remember that we need to check the full application after this. So with the program, we also can calculate various applications, the projected one, the reduced blow-in force, and find some compromise. For example, in this case, we checked what if we replace connectors in tubes from the air knife, and we keep the required pressure level, what is going to be required pressure level at the compressor, and what are going to be air cost, and they were actually higher than the cost that we have now, because simply we need to work with the higher pressure levels there. And but then you also can check what if you can reduce the blow-in force, for example, by 22%, and reduce the required pressure, outlet pressure in the air knives, how this will change. And another thing that I also want to note, that for this kind of application, we always need to remember that either we need the cleaning, we need the high flow and low pressure, or we need a very precise cleaning where we need to have a certain impact force, with the high pressure and the low flow. If we need the high flow, we easily can use the option 4 here. It's the blower, and we don't need to use a compressed air system. We don't need to compress until 7 bar to decompress until 2 bar and to have the higher flow. Or we can always work with the lower blowing force and check what is actually the real requirements of the system. So once again, once you calculated each application, you can have here nozzles, you can have here cylinders. You can check what is the pressure level here required, what is the flow required here, cost and other parameters. And after this, you can integrate it as the super component inside their bigger system. For example, here I would like to open the model of with the bigger system. And here, this air knife, it's my super component that I showed you before. So this is it's called the consumer. You can find here the consumer, it calls consumer. And you just parameterize with the flow rate and as well as with the pressure level here. And after you calculate, don't forget to put the input parameters. It's very easy to input. The program will always ask you what you forgot. And after this, you can also calculate the air reservoir, retention time, the volume that is required with a certain pressure difference. Here you see we have also still the pressure drop that is not very big, but it's still present here. You also can replace it and see what is how the system now looks like. And this is going to be the calculation of the required pressure level at the compressor, flow calculation, and as well as CO2 impact and cost. As you can see, the program allows you to calculate various applications as well as various scenarios for this application and to compare it and actually also to understand from the measurement data, from the data that are provided from the operators, where is the bottleneck of the system and how it is possible to improve it. You can find this model to download as well as the link to the software. You can download it and also play with this model and check how it works. And feel free to ask any questions.